Good afternoon, grade 8. Welcome to this lesson on mechanical systems and control. I hope that you are all okay and you are ready for the lesson today. Hi, Helene. This is what our lesson entails today. Revision of classes of levers. It's a recap from what you did yesterday. Gear systems, mechanical advantage of gears, and speed advantage of gears. Okay. Let us recap on what we did yesterday. We looked at levers and how they give us mechanical advantage and distance advantage. Okay. Can you please give me an example of a lever system which gives us mechanical advantage from the ones that we did yesterday? Is there a tool that you remember that we looked at yesterday which gives us mechanical advantage? Grade 8. Hello, 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 my children. I hope you're okay. Can you remember anything that we did yesterday that gives us mechanical advantage? Just one tool that you studied yesterday that you say, yeah, I remember this one gives us mechanical advantage. A hammer. Advantage. Remember, we said we want distance advantage on the right thongs because we don't want to burn our hands. Also, how about the bolt cutter? I thought you'd say the bolt cutter, or did you forget the name? Remember, yeah, that's the one tool that we did yesterday that gives us the best mechanical advantage. Yeah, we also mentioned that in some tools, okay? You have already mentioned a tool that has distance advantage, namely the right thongs. Which other tool? And pair of scissors. Can you think of any other system? It's okay, Natalie. Can you think of any other system that has distance advantage that we looked at yesterday? Grade 8. Distance advantage. What about the crane? When we are working with the crane, we want the crane to give us distance advantage because it must lift things to big heights. So we need that distance. So that's why it has that long arm for it to reach. So it's a system that gives us distance advantage. All right. Now, you know, our systems from hydraulic systems, we looked at distance advantage and mechanical advantage. So we'll be looking at these things. And we also calculate. Tell me, for systems that give us mechanical advantage, do they also give us a distance advantage? Is it common that we find distance advantage and mechanical advantage in one tool? Hmm? Let me remove this chat so that you can. Here is a system. I think you remember this from yesterday. Your input, a smaller force over greater distance. We measure the distance by its relation to the fulcrum. So the input distance is bigger because it is far from the fulcrum. So the input becomes greater, it's small over greater distance, and the output is great over small distance. So what is the mechanical advantage of this? Is it less than 1 or greater than 1? What is the mechanical advantage of this system? Would you say it's greater than 1 or it's less than 1? Where's my class? Hello, grade 8. It's greater than 1, Musa. Very good. It's greater than 1. Mechanical advantage, the greater sign comes before the 1. It's greater than 1, okay? But you know that sometimes we get values and we start calculating. But looking at this system, we can see that the mechanical advantage is greater than 1. But if in a certain problem we are given values, then we can apply the formula and start calculating the values for mechanical advantage. Okay. It's a revision from yesterday. This one is the other way around. The input, greater force over a smaller distance. Output is smaller force over greater distance. Looking at this, I want you to imagine the crane, okay? You can also use a lever the other way around. You can use a big input force over a small input distance. This gives a smaller output over a bigger output distance. What is the mechanical advantage of this system? Your answer could be use the greater or less than. Is it greater than 1 or less than 1? It is less than 1. I'm glad you understand this. Do you have, what advantage do we have in this system? Do we have mechanical advantage or distance advantage? Grade 8, hello. Yebo. We have distance advantage. Now you can understand by just looking at the system, you look at the input distance. So you look at the position of the fulcrum, that gives you the input distance. So if the arm is longer on the input side, you have mechanical advantage. But if the arm is longer on the output side, you have distance advantage, okay? So this is a typical system for a machine that needs distance advantage. All right. Linked levers, you remember these? Okay. Can you say these are levers? How do you know that both of these tools use levers? How do you know that? Grade 8. Are these levers? That's your answer. The handles as well as the cutting blades of these tools rotate around a pivot. You see a pivot there, okay? The fulcrum. You can see the fulcrum. So this is one lever. Yes, they are levers. There's a pivot in the middle. Very good, very good. There's a pivot, so it's a combination of two levers. Okay. How do you know that the levers are first-class levers? How do you identify the classes of levers? These are first-class levers, but how do we know that? Come, my children, grade 8. Because of the fulcrum between the handles. Chetsa. I will give you, let me see, a quarter of a mark. I will give you a quarter of a mark. How do you identify first-class levers? Remember, I taught you the FLE, the FLE. Because the fulcrum between the handles and the cutting blades. So in a lever system, what do you call the fulcrum in the cutting blades? The handles are the effort, and the cutting blades is the load. So there's a fulcrum between the load and the effort. That's how we know that, yes, the fulcrum is in the middle. Yes. How do we identify first-class levers? The fulcrum is between the effort and the load. That's how we know that these are first-class levers. There go your mark. There go your marks. The fulcrums are between the handles where the input force is applied and the cutting blades where the output force is exerted. Okay, your answer must show that you understand the levers. All right, you can identify different parts of a lever system. Okay, do both of these two give a mechanical advantage? Explain your answer. Do they give mechanical advantage? Just think about the first two slides that I did with you just now and answer the question. Yes, they do give mechanical advantage. Explain. Think about the input distance. Look at the fulcrum and the output and answer the question. Come, my children, come, come, come. Grade 8, listen. We said here, the input is a smaller force over a greater distance. Then we have the output as greater force over a smaller distance. Now, we are here. Look at the input. The input is here, and look at the distance and look at the output. Look at the distance from the fulcrum and look at the output, the same here. And my question is, do these systems give mechanical advantage? Answer me now. I've given you the answer. Grade 8, here is the answer. Yes, you got a mark for yes, because the distance from the end of the handle to the fulcrum is greater than the distance from the end of the cutting blade to the fulcrum. If you don't understand this, just tell me. Just say, ma'am, I didn't understand this. I don't know how to go past this if you don't understand it. Is it clear, grade 8? Katleho? Yeah, it's Katleho. Thanks for saying you don't understand. Let me explain this. I want you to understand me. I don't want to go to the diagram anymore. Let me look at the tool. We say in lever systems, we have mechanical advantage and distance advantage. Now let us look at mechanical advantage of these tools. We have mechanical advantage on these tools because this is the input, this is the fulcrum. When you look at the input distance, you look at it in relation to the fulcrum. So this is the input arm, the input distance, it's long. So if you do your effort here, you put your hands here and you pull this together, that's your input. And it goes over this long arm, so it becomes our input arm. From the fulcrum, the other side of the fulcrum, that is the output arm. Okay? Now, because on this side, the input arm is long, the force applied here, with a small application of force, the force is multiplied to the output. Then the output has a greater multiplication of force. Why? Because of the input distance. The input distance allows the force to be multiplied in the output. So that's mechanical advantage. But distance advantage would be different. You would have a longer output arm. In that case, you don't have mechanical advantage. You have distance advantage because the output arm accesses a longer distance than the input. So the output arm has a distance advantage. But for you to get your work done with the system, you have to apply more input for an output. So the ratio, perhaps it might be with three units of input, you get 1 unit of output if there is distance advantage. But with mechanical advantage, with a smaller input, you get a big output. And that happens when there is a longer distance, there's a bigger distance on the input side. All right. I hope you understand me. Tell me if you understand me now. Did I explain nicely? I want to move. Did I explain nicely? If I didn't, tell me I didn't understand. Okay, thank you, Nhlanhla. Katlego, is it better now? Do you understand now, Katlego? Katlego wa ka, o kae Katlego? Hello, Katlego. Technology test is on the 24th. He disappeared. Okay, yeah, but I hope that it's clear now. So we can move from levers now. We are leaving the levers. Second class levers give a mechanical advantage. Let us look at second class levers. When you look at these levers, you have your load in between. Remember the flare, the FLE? You have your fulcrum, your load, and your effort. There's the wheelbarrow. When you look at the distance from the fulcrum to the output, this is the fulcrum, and the output, the input actually has a longer arm. If you look from here to here, so it gives you a mechanical advantage. Look at the nutcracker. You have your effort here, and there's your fulcrum. So this gives you mechanical advantage. Your office punch, you have your fulcrum there, there's your input arm. You have mechanical advantage. Okay, second class levers have the fulcrum at one end and the input at the other. The output is between the input and the fulcrum. A second class lever always gives a mechanical advantage. You see, you can even look at the input arm, then it gives you the answer. The input is always further away from the fulcrum than the output. So the input arm always moves further than the output arm. This means that the output force will always be bigger than the input force. The mechanical advantage is always greater than 1. So it's MA equals to output force divided by input force is greater than 1. Second class levers always give a greater than 1 mechanical advantage. Okay, so now you can look at the input arm and just see that this gives you a mechanical advantage. Right. Third class levers give distance advantage. Third class levers. There's the fulcrum. You have your effort in the middle between the fulcrum and the load. So when you look at the input arm, this is the output. Okay, the load, this side should be the output. So the output arm is long. So because the output arm is long, that gives us distance advantage. You check the fulcrum, there's the fulcrum, there's the effort. So this is the output. So the output arm is very long. So that gives you a distance advantage. Third class levers also have the fulcrum at one end, but the output is at the other end. The input is between the fulcrum and the output. The input is always closer to the fulcrum than the output, so the output arm always moves further than the input arm. This means that the output force will always be smaller than the input force. So the mechanical advantage is always smaller than 1. By looking at the output arm, if it's long, that's distance advantage. Mechanical advantage equals output force divided by input force, and the answer is less than 1. That last levers always give a less than 1 mechanical advantage. Okay? So there's the output here in the arm. See, the output arm is very long. Okay? And the input is very short. Did you understand that? Okay, now we are going to gears. It's a revision from what you already know. Okay, now, remember, when you deal with gears, the number of teeth becomes important. When you talk about input and output in gear systems, the number of teeth becomes important. So this is a formula for the gear ratio. Okay. Now, calculations using gear ratio. Okay. The speed of a turning wheel is measured by revolutions per minute. So if the driver is turning around twice every second, it has a speed of 2 revolutions per minute. RPM is 2. RPM stands for revolutions per minute. In this case, it's 2. A speed of 2 revolutions per minute on this system will give a speed of 1 revolution per minute on the gear. The RPM stands for revolution per minute. The gear ratio can be used to work this out. This is the formula. Okay. So the formula is driver gear speed. If you want to determine the speed of the driver gear, it equals gear ratio. It means you have to calculate. Natalie. Yes, Natalie. Natalie, you can speak. Okay. All right, Natalie. So you first calculate the gear ratio multiplied by driven gear speed. And then you do your calculations and then you get your answer. So I'm just giving you the formulae. These are the formulae that we use for gears. You start with your gear ratio, where you count the number of teeth on the driver divided by the number of teeth on the output gear divided by the number of teeth on the input gear. This one is like the mechanical advantage formula because this one is the load, then divided by effort. Load divided by effort. Okay. So we will come back to these calculations when we do our exercises. Right, mechanical speed and speed advantage. Gears are wheels with teeth. They can increase or decrease the turning speed of a wheel or axle. You know when you're driving a car, you start with a small gear, just that you don't see gears inside the car. They are in the bonnet or in the gearbox. They increase or decrease the turning speed of a vehicle. So when I start my car, I start with a small gear. Then I gear up, I go to the higher gears, to the bigger gears. So when the speed is slow, the smaller gear is the driver. The teeth of two gears mesh together so that if one gear turns, the other gear will turn as well in the opposite direction. A small driver gear connected to a large driven gear will change a fast turning speed into a slower speed. When I want to slow down, I change to a smaller gear and I make it the driver. This gear system will make the wheels turn with a greater turning output force than the input turning force of the motor. This system gives a mechanical advantage. A large driver gear connected to a small driven gear will change a slow turning speed into a faster turning speed. Why? Because when the bigger gear is turning, meshed with a smaller gear, it speeds up the rotations, the revolutions of the smaller gear, so you get a faster speed. This system gives a distance or speed advantage. Okay. Now, it's a revision of gears. When you look at these gears, from your knowledge in grade 7, surely you can identify these gears. What are these gears? Can you name them? What type of gear is this? Gear A, name the gear. Grade 8. Name the gear. What is the name of this gear? Name the gears. What is the name of this gear type? In gear A, what do you call it? Bevel gear, very good, Nhlanhla. Bevel gears. What is the advantage of these gears? What is the advantage? To move stuff. Talk about motions. Okay, let me answer this one for you. You look at this bevel gear. Both these gears are rotating, but the bevel gears, they change horizontal circular movement. Horizontal circular movement to vertical circular movement to horizontal circular movement. This one will be rotating to this direction, and this one is rotating to this direction. Now, depending on where your input is, which I suspect it should be on this gear, okay, your crank wheel will be attached here. So you have your vertical circular motion being changed to a horizontal circular motion. Okay, where would you find this gear? Think. Where would you find a bevel gear? In machines, what machine? Can you name a machine? that uses this gear? Hey, Musa. Let me help you, Musa. You will find gear B in a clock. You will find gear B in a clock. But you still have to tell me the name of gear B. Bevel gears, think about your egg beater, not the electric one. The egg beater. Yeah, Natalie, the egg beater uses bevel gears. Your crank will be on this side. Okay, you'll be rotating this crank, and then the beater itself will be attached to this, so that when you do your input, which is a vertical circular movement, this part, this other gear, is making an input of a horizontal circular movement, and it is beating your eggs. Same as the hand drill. While you are rotating the crank, making circular movements on the crank, this is making these circular movements that are going to drill whatever you're trying to drill, maybe that piece of wood you're trying to drill. So this is where you will find application of the bevel gears and other machines too. And Musa, you said this you find in a clock. Can you name this gear? What do you call it? Come, my children. It's revision, eh? What do you call these gears? What do you call these gears? They are called spur gears. Spur gears. Like the Spur, the restaurant where you like to go. Spur gears. S-P-U-R. Spur gears, these ones. They are called spur gears. Yeah, they are called spur gears. Okay. What is the advantage of this? Many advantages. Give me one. Because they're on a clock, yes, they give movement. Yes, they speed up movement. They speed up movement, these. They speed up movement. Okay? They also change the direction of rotation. Because if you look at this, any two mesh gears, they rotate in opposite directions. Right? Now, this one, we have already said we can find this on clocks. What is the name of this gear? Ah, you know it. No. Yeah, we find it on the gate motor. Yes, Musa, this one. We can find it on the gate motor. What is the name of the gear? This is called a rack. I'm giving you a clue. So what is the name of the gear? It's rack and pinion. Very good. Yeah, so just a reminder of what you did in grade 7. Now let us look at gear calculations. Study the drawing of a simple gear train. I like this drawing because I want to show you how you graphically represent gears. Now, this is how you draw if a question says, draw this gear system using graphic symbols. These are graphic symbols. Or if they say, draw a graphical representation of this gear system, this is how you draw it, okay? It looks like this, but this is not a graphical representation. But this one is a graphic because it has graphic symbols. Now, let's see. This is for the axle, and this is the gear itself. And the outer line is for the cogs or the teeth. Now, if you can look, these gears, they interlock. They are in a gear mesh because the lines overlap. Now, because we cannot see the teeth and we cannot count them, we are given the value. So the T is for the number of teeth. So this one, this very small one, has how many teeth? 40. And this bigger one has how many teeth? 480. So this one is a lot bigger than that. But the A is for the driver. Okay? The A is for the driver gear. So this small gear is the input. That is where the input is. It is the driver gear. Now, you understand this system now. You understand what is happening here now. Answer the questions that follow. If A moves in an anti-clockwise direction, in which direction does the driven gear move? It moves clockwise because any two meshed gears, they rotate into different directions. Calculate the mechanical advantage of this gear train. Let me take you to the calculation. Mechanical advantage is number of teeth, mechanical advantage. It's load divided by effort. So number of teeth on the driven gear is the load. Divide by number of teeth on the driver gear, that is the effort. So you have your 28 teeth and your 12 teeth. Let me see. These values are different from this, okay? But let us look at the calculation anyway. Mechanical advantage is 7 divided by 3. So this is the answer. 2.33. Mechanical advantage is 2.33. Okay? So this is just a typical calculation for mechanical advantage. What load would the driven gear be able to carry if we applied the 40 newtons, that's the force, on the driver gear? Okay, what is the speed ratio of this gear train? What is the force ratio of this gear train? How much faster or slower is the driven gear than the driver gear? Okay, let us just end it here. We will do more gear calculations, and we take these calculations from your DBE technology assessment item banks. They have the questions and the answers for our technology from grade 7 to 9. So if you get into the assessment item banks, you look for gear calculations, you will find examples of this, but I will go through them with you in our lessons, okay, so that you understand the calculations and the application of the formula for gear calculations. For now, let me leave you and leave you grade Bye, Nhlanhla. Bye. Bye, children.